All right, guys. I'm going to do a brief lesson on exponential properties using the product rule and the power rule. All right. And what this says is that if I have the same bases, think about an exponent for a second. If you have the base and you have the exponent up here, if I have the same bases and I'm multiplying them together, I'm going to add the exponents. So if I have 2 to the third power times 2 to the fourth power, that would be 2 to the seventh power, which would equal 128. And I'll explain that a little further here in just a second. The next one is the power rule, which means that if I have a base that is raised to a power that is raised to another power, then I'm going to multiply those exponents. So if I have 2 to the third power that's raised to the second power, that's 2 to the 3 times 2, or 2 to the sixth, which gives me 64. Now, looking at um, the product rule, what we're saying is, if I say to you I have 2 to the third power, and I'm multiplying that by 2 to the fourth power, think about it for a second here. If I have 2 to the third, then that's saying I have 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. Well, if I collect all of these 2 together, that gives me 2 to the seventh power. So that's where that product rule comes into. Similar when we're looking at the power rule. So in the power rule, we're saying, okay, if I have 2 to the third and I raise that to the fourth power, okay, then that's saying that I have 2 to the third times 2 to the third times 2 to the third times 2 to the third. Breaking that down even further, that's saying, well, shoot, we've got 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2, and the last one, 2 times 2 times 2. When I collect all of these 2's together, we have 12 of them. So that's where we get to the multiplying of the powers themselves. So if I look at an example here, um, I can see here that I've got a number now that I've got to mess with. Now, kind of going back to the example here for a second, we used numbers first by saying when we're multiplying the exponents in the product rule, we were saying 2 to the third times 2 to the fourth is equal to 2 to the seventh. Okay, the same thing happens with variables. If I have the same variable as the base, then that would be x to the seventh. This is not the same thing as saying x to the third times y to the fourth. These are not the same bases, so I cannot combine them together. So if we look at our examples for this, I'm going to group everything together. So I'm going to group first my numbers, which all I have here is a 2. Then I'm going to group my n's together. So n to the negative third times n to the fourth. Well, that gives me 2 times n to the negative 3 plus 4, which gives me 2n to the first power. Same thing here. We get to this and we have grouped the numbers 3 times 4 times 4. We group the v's, b to the negative 2 times b to the negative 2 times b to the 2. Well, 3 times 4 times 4 is 48. When I add these exponents together, negative 2 plus negative 2 is negative 4. Negative 4 plus 2 is negative 2. We're not done here yet because I cannot leave a negative exponent. So then we have 48 times 1 over b to the positive second, because remember, when we have a negative exponent, b to the negative 2 is equal to 1 over b to the positive 2. And when I multiply this through, I have 48 over b squared. Let's look at the next example here. I'm going to group my u's together. So I have u to the negative 1 times u. And remember, if I don't see an exponent, I assume there's a 1 there. Then we have the v to the negative 4 times v to the 4. Well, u to the negative 1 plus 1 is u to the 0. V to the negative 4 plus 4 is v to the 0. And anything to the 0 power is 1. Next one, group the numbers together. 4 times 4. Group the v's together. V times v to the 4th. And then we group the u's together, which is just one of them. Again, remembering that I have a 1 here for my exponent, I have 16 v to the 5th, u to the 2nd. Bringing in a little bit more variables here, group my numbers together. 4 times 2. I'll group my h's together. I have h to the 3rd times h. Group my k's together. I only have one k, k to the 3rd. And group my j's together, j to the 4th, excuse me, j to the 4th times j. So this gives me 8. 3 plus 1 is 4. There's no other k's here, so that one isn't going to change. And j to the 4th times j is j to the 5th. Alright, so the last one, 2 times 3, q to the 4th times q to the 2nd, r to the 3rd times r to the 4th gives me 6, q to the 6th, r to the 7th. Alright, so that is product rule. Now when we get over to power rule, remember inside the parentheses I have two different terms here. I have a 3 and I have an x to the 4th. This power of 2 goes to both of those terms. So that's going to be 3 to the 2nd times x to the 4th, also raised to the 2nd. Well, 3 to the 2nd power is 9. X to the 4th raised to the 2nd. We have a power that is raised to a power. 4 times 2 is going to give me back 8. Alright, again, this exponent goes to both of these terms. So I have 3 to the 3rd times n to the negative 1 that is raised to the 3rd. Well, 3 to the 3rd power is 27. Negative 1 times 3 is negative 3. I cannot leave that negative as an exponent, so we have 27 times 1 over n to the 3, which gives me a final answer of 27 over n to the 3rd power. And that's how we do that. So if I have more than one variable in the parentheses, again, the same thing happens. This 3 goes to the 2, it goes to the u, and it goes to the v. So I have 2 to the 3rd, u to the 3rd, v to the negative 3rd to the 3rd. Well, 2 to the 3rd power is 8. We have u to the 3rd, and we have v to the negative 9. So again, I've got to fix this. So we have 8 u to the 3rd times 1 over v to the positive 9, giving me 8 u to the 3rd over v to the 9th. We will look at one more example. This last one, we have 4 to the 4th power. We have h to the negative 4 to the 4th power. We have j to the 4th to the 4th power. And we have k to the 3rd to the 4th power. 4 to the 4th, I believe, is 256. H to the negative 4 to the 4 is h to the negative 16. J to the positive 16. k to the 12th. When I simplify this, I'm either going to multiply everything by 1 over h to the positive 16, or just simply move him down to the denominator. And that gives me 256 times j to the 16th times k to the 12th all over h to the 16th. Looks more complicated than what it is. Just again, do the best you can at practicing through the worksheet, and on Tuesday we will go over this together.